Hello everyone, I hope you all are doing great. We heartily welcome you all to our YouTube channel CAD CA Master. If you enjoy what you see, hit the subscribe button and turn on the notifications so you never miss an upload. Hello everybody, I hope you all are doing great. So in the previous session we had gone through the NVH analysis on the pump, where we try to extract the BCH curves on the required mount locations to find out the excitations, and we try to optimize the plates, right? So now there's one more special case where we need to deal with the frequency response analysis. So in that we especially need to extract the ODS. Okay, so how we can do that is the question, right? So this is specially meant to extract the particular frequency. Let's say we had seen, right, a 265 hertz and the 310 hertz in the previous session which we had covered, which were the peak resonating frequencies which we tried to improvise. So what if we would like to see the excitations, or how the component is behaving in the operating conditions with that particular frequencies of 310 and 265 hertz? How do we find out? So for that, the ODS plays major role. So we're gonna see how exactly we can set it up and find out the frequency response for that particular frequency during the operation conditions. Okay, well, so agenda here, you could just see we're gonna just take the same model. So we'll try to just modify the deck as per the ODS requirement. So this NVH deck, we'll just simply modify it. So we'll add just FREQ1 card, where we can just define FREQ card, where you can just define the independent uh, frequency values, so that we can extract the uh, excitations for that. Well, let's get started with this. Yeah. Okay, so this is the model. So which I said I'm just going to refer the previous NVH model, so which I try to set it up. Yeah, so I'm just looking for the thickness. So this plate has 5 mm thickness, which I had considered earlier. That's fine for me now. Let's go to a frequency card. So here you could see this FREQ1 card. So yeah, so I need the FREQ card where I can just enter the frequency value. So as we mentioned, 265 hertz and 310 hertz were the critical one, and I would like to see the excitations, and yeah, uh, just to check how it is going to behave. So aside, I'll define it as 100, so just to avoid confusion. So I would like to have 4 frequency cards with the same SID. You need to change because I'm going to add these FREQ cards to the mounts. So we had seen, right, 4 particular mounts were critical, and we try to optimize it by using the thickness 20. So that mounts I'm going to consider. Well, so in the header we'll try to modify it. So I'm just trying to modify the deck. Well, so here I have the FREQ1 card. Okay, so I think we deleted the set, right? There was a frequency 1 card, so I think we need it back. So what I'll do is I'll simply add that card again, FREQ1. So here it should be we had 5 iterations, 200 things, right? So I'll just take it 1 increment and 1000 number of sets I need. So FREQ1, I have defined it so that I will be extracting each and every hertz, so that I can easily call 265 and 310. So if I, yeah, even if I have it 5 multiplication also, I might have got it, but no issues. Well, so I need to remove this DRESP. I'm not looking for that one. So here I need to call the frequency. So you either mention everything or else you can just keep it as it is. So well equals to, so it should be any of the frequency cards 100 to 13. In some cases, some other frequency also you might need to define just for information, so you can do that also. Yeah, SPC has been defined, so I'll just have frequency written here so that it should not create the issues while uh, running the deck file. Yeah, I'll just copy the subcase because I need to repeat it for few deloads on that particular mounts which are very critical. So yeah, so I'll delete these all. So a lot of subcases are there, so it is not needed for me now. I need subcase 11, so I can just rename it as subcase 5 because I have only 4 subcases on the top, so I think this is fine. Yeah, very important is the deload, how we can identify which are the mounts we are going to consider. Correct. So for that, you can go to BC sets, or you can first refer the deload from the load sets. R load we could see. Yeah, so this is 2. I'll just see the SID. Yeah, as per the SID it is that. So 2, 3 is this, 4 is this, but I'm looking for yeah, these are fine. So I think 1 correct, 3, not 2, it should be 1, 3, I think 5. Yeah, 5 is needed, and then 7 I think. Yeah, so 1, 3, 5, 7 are the critical mount for me, so I'll be taking these into account. So in the load set also it remains the same, you could see BC set. So 1, 3, 5, 7. Yep, this is fine. So I'll just simply go and call these in the D area, sorry, D load. So here it is 1, this is fine. If you want, you can cross verify. If I just shift question mark, it locates the same location, so I don't need to worry now. So it should be 1 here, and it should be 3, and here it should be 5 and 7. Yeah, so likewise you can set it up. I think this is all you can do for the ODS run. Here, yes, you need to define it cards 2, so 102, 103. You can even call single one also, because in the all the FREQ cards, so same frequency we have it, so we would have called only one, so no issues. So for information, so you can have multiple FREQ cards, so that you understood, right? Yeah, well, so just for information, we just checked these FREQ cards, it's fine. Well, finally I would like to have the global output for stress displacement first, set all, and then ESE, and then all, and then here the stress. Yeah, instead of set you can just call for all. Okay, so this is globally we have selected, so all these subcases will have these all the outputs. Yeah, so finally you can just output the stack to run this particular ODS analysis into ODS Optistruct solver. Yep, so you can just name it as frequency response ODS on pump and save it up. You just need to output all continuation lines, comments none, fine. Yeah, so now we can just take this model into Hyperview. Just go to Hypermesh in short. So I have a shortcut over there. So I'm just switching to Hyperview. From there I can switch to Hypermesh. Yeah, so you could see there's a bottom. We have the Hyperview activated. You can switch to Hypermesh. So this is one click here. Once you switch here, go to File, Import. So default is Optistruct, fine for me. File, Import, Solver deck, and then file location. So it should be frequency response ODS on pump. Import the file. Okay, we have it here. We have a few warnings, but fine, no issues. There's no errors. Zero errors shows there in the warning. So we'll switch to the solids. Isometric wave. The wave is different. No issues. Yeah. So I'll just switch to analysis, Optistruct. Run option is analysis. Just run it once. So as we have given the frequency range from 0 to 1000 Hz with the increment of 1, it might take some time. So yeah, if you want to run this kind of analysis, guys, I would recommend you to take one, I think not 64, yeah, 128 GB RAM. You should have it for this kind of analysis in ANSA, preparing the text and solving it by using Optistruct. Least possible requirement is 128 GB RAM. So don't purchase the laptops, workstations. Try to invest on CPUs and build your own systems. Yeah, analysis is completed here. You can directly switch to results from here, or else you can just open the new Hyperview window, and from there you can open the H3D file. Okay, so I'll be just going to again import a model, or else you can directly use this load the model option. From here you can just select the H3D file, just apply, so the model is loaded. Yeah, could see this is fine. So now there are coordinate systems activated, so I'll just go to systems and I'll just hide these all, and again just animate this. Could see supports are fixed, very important, guys. So if they are moving, then your assembly is not subcase doesn't have the SPCs in short. Yeah, now it is fine. Could see the subcase 2 on the second mount with the 310 Hertz. Subcase 3, it should have 265 Hertz to have that mount vibration. So this is subcase 4. So I'll switch to 165 Hertz. You could see that particular mount we have called it. It should be, I think, 5th mount. Yeah, this should be, yeah, 7th mount it is. Exactly the same, right? So yeah. So if you consider mount 2, it should be 310 Hertz. So this was the critical one. 265 Hertz, I don't see any impact on the mount. So yeah, you could see that should be, I think, first mount. And if I switch to first one, you could see this is the third mount, and which is exactly doing the same. Yeah, you can switch to elastic strain energy, elemental strain energy, sorry, and then we have the stress plots. So now it is globally taking for whole model. So what you can do here is you can simply isolate the plates. Just pause the animation. So these are the options here. It's isolate option, and if I just isolate this one, so only single plate will be isolated. So you can again show all. So instead of isolating, you can use hide option, so that again isolated, sorry, switch back again, show all, hide this one. Yeah, this is also fine. So you can see these are two pleats. So I'll just switch to only displayed, not the whole component. So these are the elemental stress plots. Not much impact, but yeah. Could see this is how they are exciting. So here this is the fifth mount, and there should be the seventh mount, right? Yeah, so this is how you can just see the behavior of that particular excitation at a particular location with a particular frequency. So the displacement, it is, yeah, slightly fine, but no issues. So here I'm only concerned about the plate excitation, how it is exciting and what might be the impact of it. You could see this is exactly on the first mount. This is the third mount, especially on the pleats. You can just show all. So right now we have just activated the results only for that particular component, so you could able to see the fringe the counters on that particular pleats itself, right? Yep, so you could see these are the excitations, and for particular frequency this is how it looks like. Well, I think that's all from the session. To summarize, so we had gone through the deck preparation in ANSA by using the frequency cards. We set it up the ODS stack, and then yeah, we used R load, D loads, and the table D cards, which is already set from the previous session. And we try to just see how the component is exciting at a particular frequency on the particular grid point. Yeah, I think that's all from this session. If you people are freshers and you would like to become a C engineer, or if you're looking for any kind of personalized trainings, please do contact us and reach out to the given mail ID and contact number so that we could help you out to train you guys. Well, that's all. Thank you. We heartily thank you all for watching this video. If you enjoyed this video, don't forget to hit the subscribe button and give it a thumbs up. Follow us on Facebook, LinkedIn, and Instagram for behind the scenes content and the updates. Stay curious, stay awesome, and see you again in the next video.